Today I will talk about one distributed switching called bridging. My topic will divide into 5 parts. First, the definition, 2 types of bridges, and then try to tell some details about a transparent bridge and bridge process, followed by the switch spanning tree protocol, and then give some pros and cons of the bridges. Firstly, let's move on. First part, what's a bridge? What's a bridge? It's a type of the internet switch implemented at the link layer, and some specific technology can be used for learning passing and forwarding traffic appropriately. In terms of whether the interstation need to be aware of the bridges, there are 2 types. In other words, if interstation don't need to know bridges, they are transparent bridging and act independently of the interstation and other bridges. If bridges should be known for routing by interstation, is a source routing bridge. So let's talk about transparent bridge. This type of bridge have benefit to any station because it can continue using the legacy protocols and doesn't have to be reconfigured, which means save time. So for achieving this transparency, any station shouldn't participate in the bridges. Bridges should not only forward unicast, but also must forward multicast or the broadcast traffic is hard for them, and it should realize reliable transform such as ordering and uniqueness. So what are the limitations? Even though they can increase the throughput and decrease the access delay during the fewer station content, it also decreases reliability resulted from the loss within bridge when buffer is full and increase the propagation delay when incoming frame within the buffer. The bridge process can divide into 3 steps. When a frame arrives, update the database and record the direction of source. Look up the source in the database. If it exists, just record the variable port and mark in the recent thing. And else create a new database in the free space and fill out certain frames, forwarding remaining frames. Learning by the source lookup is very important. So first process is listening promiscuously to all the frames so that the bridge can learning all the information from the bridge frames. They also need to observe the source address of the frames, assuming that the link are bidirectional. Uh, that's an example of the bridge. That's an example of the bridge process. We can look at each database entries contain the 5 parts. The address of the station is a line source and destination address. When frame come in, bridge will check the database to find whether the address exists or not. If it is a new address, bridge just create a new database entries and flooding it to other port, exclude the arrival port. If the destination address is known, just forwarding the frame directly to the reachable port. Furthermore, a bridge use replacement policy to update the destination address by setting flag in the used port. Whenever address is used for the destination, it will set recently flag, and during the 5 minutes, if the address hasn't been used, and when the database is full and the new address come in, the entry will be replaced by the new one, and it also uses aging policy to update the source address set recently flag in the same part. In this case, during the 5 minutes, if the address hasn't been recently observed, the bridge will delete them. So, and the second step is filter out certain frames according to the policy to filter frames multicast traffic used to the spanning tree protocol. Look up the destination in the database. Discard having done if the output part equal to the arrival port, which means the frame are in the wrong direction, and then forward the remaining frames depending on whether reachable or not, using the flooding or forwarding directly. It's a spanning tree protocol. The first thing we should know whether loops arrives interconnections multiple lines with a high reliability, which means that the more than one backup bridge can link to the lines which will have the redundancy auto configuration also create loops. So the loops are also bad because it duplicates the received frame proliferate and loops endless. How to prevent it? We just use the STP spanning tree protocol to create a loop-free logical topology while maintaining the physical loops. So how to create a spanning tree? Firstly, we should compare. It should compare in the message called the configuration bridge protocol database unit sent by the bridge periodically. This method should often be compared to determine which is better. The link layer address is lowest means better, and the ordering is also important. Later comparisons are also made if the earlier comparison failed to differentiate. The steps of the spanning tree protocol. Spanning tree is like that. Elect a root by the root ID. Identify the root port for each line. Elect the designed port and designed bridge, and then the bridge enable the root and designed port, but disable all other ports. After doing that, maintain the topology through periodical advertisement with PBDU. It's an example of the creating spanning tree. Initially, each bridge thinks it's the root by setting BPDU message to each other finally. Bridge 1, bridge 2, 3, 4, 5, no, bridge 1, which has the lowest bridge ID is the root, and then bridge 1 set its port cost to 0. In this moment, we should identify the root port that lead towards the root with the lowest cost for bridge 2, 3, 4, 5, and then we enact the design part of a design bridge of each line that has the lowest cost to reach each line. For example, for Y line and the Y line, a designing part V2 has a design part this part to Y line and VY. Next, enable all the root port and design port, but disable all other port to create a spanning tree. Finally, maintain the spanning tree through periodic advertisement. After doing that, establish the spanning trees like this diagram. So there are several advertisements for the bridging. It's simple to use and transparent, and self-learning requires minimal or no configurations. It's simple to implement to make a fast speed. Only process mark layer headers. Even though the bridge communication with other use the link layer address. Don't modify the frame so that no need to recalculate CRC exactly. While it's some disadvantages, large address to classify may create large database and more capacity. Implication of broadcasting may cause a problem. A broadcast or suboptimal routing may slow the convergence. So that's all of my talk. If you have more interested in it, you can find the reference below. Thank you.